User Creator Demore, can you please help with trig identities? Okay, can do that for you. Since you are here and asking, I'm gonna do a few problems. Proving trig identities. Okay, grade 11. So let's look at an example. Okay, so let's look at a trig identity such as this. They say prove that cos to the power 3x plus cos x times sine squared x is equal to cos x. Okay, so with trig identities, you always have a left-hand side, right? So this is your left-hand side. This is your left-hand side expression. Then you have a right-hand side expression. And so this is your right-hand side expression. So what you are intending to do, you want to be able to take the most complicated side and then simplify it so that you are able to, so that it is exactly the same as your right-hand side. If it is the right-hand side that is complicated, you're supposed to simplify it so that it looks like the left-hand side. If it is the left-hand side that's complicated, you're supposed to simplify it so it looks like the right-hand side. So I'm going to ask those who are in the live, which side is more complicated? Alright, and the side that is most complicated, you usually see it by it not being reduced to a single term. Okay, so for instance, in the left-hand side here, we have how many terms? 1, and then we have 2. Terms are separated by a plus or a minus sign. So there's 1 term, 2 terms. On the right here, we have 1 term. So that would suggest that the left-hand side is more complicated. Now, with that said, the next thing you need to do, so the method is that you need to, 1, choose the complex side, right, to simplify it. Okay, and the way that you simplify it is you actually do the following. You can either apply strategy 1, which is to apply simplification. Now, simplification would mean that if there are like terms in that expression, you must add or subtract them. If there are fractions, you must add or subtract them. Okay, now you must remember the rules and the laws that have to do with fractions. Remember, in order for fractions to be added or subtracted, you usually find the LCD, right? And then after you find the LCD, you actually make the denominators the same by ensuring that you multiply so that the LCD, which is 6, can be able to reflect. So for instance, in order to make 2 to become 6, which is your lowest common denominator, you basically times by 3 in the denominator and you times by 3 in the numerator. Same thing with this side, you times by 2, you times by 2. Okay, that way you are able to get 3 over 6 plus 2 over 6 when the denominators are the same. That allows you to add the numerators whilst you keep the denominator. So the rules that apply to simplification, meaning if there are like terms, you add them. If there are fractions, you add them. If there's a reduction that is there, you simplify it. For instance, sine 180 minus theta, you must be able to reduce function values so that they can be expressed as single terms. So that's what I mean by simplification. All your algebraic skills that you learned about addition and subtraction of like terms needs to come to the front. All your skills with regards to addition and subtraction of fractions needs to come to the front. Reduction, you need to know how to reduce. function values and co-ratios. Also, you need to know how to multiply and divide fractions. So that's what I mean by simplification. Simplification is one of the important strategies that you apply, which you first check before you do anything else when you are trying to simplify that complicated side. The second strategy you can apply is factorization. So if after all simplification is done, you can then look at factorization. Now remember, in the previous grades, you learned about highest common factor factorization, difference of two squares factorization, trinomial, quadratic trinomial factorization. All of these factorizations, grouping factorization. So all of these, you need to be able to know how to do them, all right? So that's how you are able to, that's the second strategy you need to apply when you are trying to basically make this complicated or complex side become more simple. And then the third strategy is being able to basically use your one square identity. And by square identity, there's this identity that says sine squared theta plus cos squared theta is equal to 1. This one, okay, you need to be able to know when the sine squared theta plus cos squared theta, when to actually write 1, or when to change 1 to become sine squared theta plus cos squared theta. Also, you need to know if the subject is sine squared theta, you can express it as 1 minus cos squared theta. Or vice versa. If you have 1 minus cos squared theta, you can express it as a single term, sine squared theta. Also, if you make cos squared theta the subject, you know that cos squared theta is equal to 1 minus sine squared theta. And remember also, in conjunction with that, this here, you can also be able to factorize, because 1 minus cos squared theta, in some cases, you will be able to factorize 1 minus cos squared theta because this is a difference of two perfect squares. Okay, so people, please, these are the 3 critical strategies that you need to know how to apply when you are trying to simplify either a left-hand side or a right-hand side. When you have checked and simplification cannot be done, then you move on and check, can I factorize? When you have checked and factorization has been done, and basically you move on to the next step, you must go back and check, is there any other simplification that can be done? If simplification clearly cannot be done, you must check factorization. And if both of these strategies fail, then you must always check, can I convert an identity? So this is a square identity, and then the other identity is the quotient identity, which says tan theta is equal to sine theta over cos theta. When there is tan, you can express it as sine theta over cos theta. When there's sine theta over cos theta, you can reduce it back and write it as tan. Okay. Now, guys, I hope you understand. Like I said, whenever we are proving an identity, you must choose the side that is most complex, all right? Then you must simplify it. How do you simplify it? You employ one of 3 strategies, and you interchange between these strategies to ensure that at the end of the day, you have that side simplified. You first look at simplification, and by simplification I mean if there's an addition of and subtraction of like terms, you do it. If there's an addition and subtraction of fractions, you do it. If there's a reduction that needs to be done, 180 minus, 360 minus, 360 plus, angles greater than 360, negative angles, you reduce them. You know how to apply reduction by now if you are at the point of doing identities. Multiplication and division of fractions, you need to know how to be able to multiply and divide fractions and the rules that are attached to that. Then, if simplification has been done fully, and basically you are now checking what more can I do, the second strategy you apply is factorization. Now you need to know how to factorize, applying all the different types of factorization. Then the very last strategy is that if simplification and factorization have obviously been done and you cannot do anything more than simplify again or factorize again, then you must check identities. Can you convert to identities? You look at your situation and see which identity can we use and convert so that we can simplify that particular thing further. So let's come back to the question. You have cos to the power 3x plus cos x times sine squared x is equal to cos x. So first step, we choose the complex side. The complex side, you can see guys, is the left hand side. So I'm going to write LHS is equal to cos to the power 3x plus cos x times sine squared x. Step number 1 done. Okay. Then step 2, I am going to check, can I simplify? In other words, are there like terms? Okay. Is there an addition maybe of fractions that I can basically apply? Is there reduction that I need to apply? Is there multiplication or division of fractions that can be applied? That is strategy number 1. So if I look at this, cos to the power 3x plus cos x times sine squared x, how many terms are in this expression? There are 2. Can I simplify? Meaning, are these like terms? No, they are not. So that means addition and subtraction cannot be applied. Are these fractions? No, they are not. So that means addition and subtraction of fractions, multiplication and division of fractions. I'm not going to apply any of these simplification strategies. Do I have any reduction that I can apply in this expression? There is none. So that means for my simplification strategy, I cannot apply nothing when it comes to simplification. Step 2, look at my factorization strategy. In that expression, can I apply any type of factorization? So let's go back here. Cos to the power 3x plus cos x times sine squared x. Okay, so from what I can see, there is a highest common factor here. Okay, and that highest common factor that I can see is actually what? Cos x, because I have cos to the power 3x plus cos x times sine squared x. So that means I can take out cos x. Okay, cos x I can take out. I'm sure you guys can see that. I hope you guys can see it. Then I can leave inside the bracket cos squared x, because when I take cos x and multiply it with cos squared x, I get cos squared x plus what is left on the right hand side, sine squared x. Do you guys see that? So I have just applied strategy number 2, because strategy number 1 of simplification, there was nothing I could do with strategy number 1. So I move on to strategy number 2, and that is I factorize. So I took out cos x. Now that I have this, I look at my expression again. This is one term. I have cos x on the outside. Inside the bracket, I have cos squared x plus sine squared x. So I go back to strategy number 1. Is there any simplification I can do? Meaning addition and subtraction of like terms. Okay. Fractions, addition, reduction, simplification, multiplication and division of fractions. So there's no simplification from the expression that I now have. This was the question, Kanye. Cos to the power 3x plus cos x times sine squared x is equal to cos x. That was the question. Okay. Now, I took the left-hand side, which is most complicated, cos to the power 3x plus cos x times sine squared x. And now I applied After choosing the complex side according to the method, I need to then simplify it, okay, by either adding and subtracting like terms, adding and subtracting fractions, reducing if there's a reduction formula, or multiplying and dividing fractions. None of that was there, so simplification was not a strategy I could employ in attending this question. Strategy number 2 says you factorize if there's factorization. So if we look at strategy number 2, there is some factorization that I can apply, because I have how many terms in the expression? I have 2 of them. Why do I say there are 2 terms? It's because terms are separated by a plus or a minus sign. So there's 2 terms. What sort of factorization do I see in the expression? Cos to the power 3x, and there's cos x. So there is a highest common factor in the expression, okay? So since there's a highest common factor in the expression, I can apply that highest common factor factorization, and that is I take out cos x. Take out the common base that has the lowest exponent. This is to the power 3x. This one is to the power 1x. So I take out cos x, which leaves me with what in the brackets? Cos squared x plus sine squared x. After doing this, I revisit my strategy. Can I simplify any further? Meaning, can I apply anything here? There is nothing here. No like terms, no fractions, no reduction, no multiplication and division of fractions. Can I apply strategy number 2? No, I cannot, because there's no further factorization that can be done here. Then I go to strategy number 3. Is there an identity that I can apply in the expression that will simplify my answer even further? So I'm sure you guys can see that cos x, brackets mean multiply, inside this bracket, cos squared x plus sine squared x is equal to what, guys? That is the what? It's the identity. So in the place of cos squared x plus sine squared x, I have 1. Okay? And then what's cos x times 1? It's equal to cos x. If you go back, guys, to the identity, this was the left-hand side, that was the right. I've proven that the left-hand side is indeed equal to what? Cos of x. So that means this is the right-hand side. Okay? Therefore, I can say left-hand side is truly equal to right-hand side. Identity proven. Guys, I hope you can see that when you play this game of looking at the strategy that you can apply, it helps a great deal. Okay? Let's move on and check another identity. So that was 1. Let's look at another one. 1 over 1 minus sine x plus 1 over 1 plus sine x is equal to 2 over cos squared x. Okay. Now if we look at this identity, once again we are asked to prove the identity. Okay. So what do we have? We have a left-hand side and a right-hand side. So whenever we are proving an identity, we need to choose the most complicated or complex side, and we simplify it so that it can mirror the other side. It can have the same sort of like outlook as the other side. So if we look at the left-hand side, we have how many terms on the left-hand side? We have 1. The plus sign separates 2. So we have 2 terms on the left-hand side. Okay. On the right-hand side, we have 1 term. It's 2 over cos squared x. Okay. Now, with that said, on the left-hand side, we are going to take that left-hand side and we are going to work it. And when we work it, we are going to go back to our strategies. Strategy number 1 says we simplify. And in our simplification, if we have like terms, we add them. We don't have like terms here. Fractions, we add or subtract them if we have them. Now, guys, here we have fractions, okay? We have 1 over 1 minus sine x plus 1 over 1 plus sine x. So what we do is we are going to actually take these fractions and add them. And when we do that, we are going to apply what we know as the addition of fractions. Now let me just suggest, if there are two fractions, guys, there is a very simple way in which, without really even thinking, especially if there are two fractions. If there are three, then you cannot apply this strategy. But I want to just suggest, if there are two fractions and they are added or subtracted, you can apply the following approach. All you do is you take this 1 plus sine x, okay, you multiply it with the 1. So that becomes 1 into 1 plus sine x. That becomes 1 plus sine x here at the top. You then take this denominator, you multiply it with this numerator on the side. Okay, this is a positive, so we have plus 1 into 1 minus sine x. And then your LCD, you multiply the two denominators for your LCD. So you have 1 minus sine x into 1 plus sine x. And that has completed your addition of the two fractions. Okay, now this is the same thing, guys. Okay, yeah, it's a very fast method, especially when you have two fractions. Some people I know will insist that yes, you must write down the LCD. So the LCD here is 1 minus sine x plus 1 and 1 plus sine x. So obviously you would write down your LCD as the product of the two. Then you would basically try and make your denominators become like your LCD. So you would ask, what do I have to multiply 1 minus sine x with to get this product? So that means we are missing 1 plus sine x. So you would multiply 1 by 1 plus sine x at the bottom, and you do the same thing. Multiply by 1 plus sine x at the top. Do you see? Here it is. Here it is. You do the same thing with this fraction. What is missing? What do I need to multiply 1 plus sine x with in order to get this product? You multiply by 1 minus sine x. You do this at the bottom, you do this at the top. There it is. Do you see that? Okay? Yeah. And there's an insisting thing that you put brackets here, because obviously this is also here there 1 into 1 plus sine x. Do you understand? Because you take this, you multiply with whatever is there. Since you have two terms, you're going to have to eventually distribute the 1 inside the bracket. Also, because you have two terms that you've multiplied 1 with 1 minus sine x, you will also distribute the 1 inside the bracket. So let's go ahead now and simplify the top, because when the denominator is the same, you can now add the numerators. 1 times 1 is 1, 1 times plus sine x is sine x, positive 1 times 1 is 1, 1 times negative sine x is negative sine x over, obviously, 1 minus sine x into 1 plus sine x. Okay. Like terms at the top, okay, because we're still simplifying. 1 plus 1, that will give you 2. Sine x minus sine x, that gives you 0. Okay, so I'm left with 2 in the numerator. And then this here at the bottom, I can actually FOIL, multiply out. Okay, and if you see 1 minus sine x into 1 plus sine x, what's 1 times 1? That is 1. 1 times sine x, because I FOIL, that's a plus sine x. Negative sine x times 1, that gives you negative sine x. And then last but not least, negative sine x times positive sine x, that gives you a negative sine squared x. In the middle, you have like terms that can be added and subtracted. So that means you're going to have 2 over this, and this gives you 0. You are left with 1 minus sine squared x. Do you see that, guys? And then finally, 2 over. This here is an identity. This here is an identity. 1 minus sine squared x. So that means you go to your identities. Remember, what is the single term that 1 minus sine squared x is actually referred to. It is equal to the identity cos squared x. If you go back to your question, do you still remember what we had? We said 1 over 1 minus sine x plus 1 over 1 plus sine x is equal to 2 over cos squared x. Ooh, that is the right hand side. So I've just simplified. This is the right hand side. Then I can conclude, okay, that the left hand side is truly equal to the right hand side. So that is how I basically move in answering this question. And look at this, at every step I'm always checking my strategies, my 3 important strategies. So initially I said there were 2 fractions and I had to simplify the fractions. Remember, here there is addition of fractions. So we go straight ahead and we apply what we know about addition of fractions, guys. And when we've done that, then that allows us to add and subtract the like terms. We distribute the 1 inside this bracket, we distribute the positive 1 inside this bracket. Then we add and subtract the like terms, which is further simplification. Okay, so if you can see, we've been applying the simplification strategy all the way until we get to this place 2. In the bottom, we had to distribute. Once again, that is a simplification strategy of products. We are multiplying out, applying FOIL, an algebraic thing that we did. Okay, and then now in the denominator, after simplifying, we see that, okay, we now have arrived at 1 minus sine squared x. Then we have to ask ourselves, what strategy can we still apply? Is simplification still relevant? We are done with simplification. We move on to the second strategy. Is factorization applicable? No, there's no factorization, especially considering that we want our answer to be 2 over cos squared x. We are constantly looking back to see what is our right-hand side. So if we look at the denominator, factorization, the strategy will not be applied. We go to our third strategy. Is there an identity in the mix? Yes, this one. We apply it. 1 minus sine squared x is equal to cos squared x. Done. This is the right hand side. There it is. And therefore we are done. So people, these are really like, if we are constantly moving between our strategies, then we should be fine. There should be no sort of challenge or problem. You know, the challenge or the problem comes when people forget the important strategies. Then that's where trouble happens, you know. Okay, I just want to do another one, just so that you guys can see that this thing of strategies is very important. Okay, I saw in the comment section someone saying he wants me to do one where there's the reduction of 270 and 90. I'll do one just now. I just want to do this one and then I'll go back and do it. Yeah, Matabo, I see what you are laughing at, where Kanye said the answer is cos x. Let's be very clear about our identities and the expressions of our identities so that we don't make silly mistakes, okay guys? Then once again, we have a left hand side, we have a right hand side. Okay, remember our 3 strategies that we are moving in between whenever we are dealing with these. Is either we are going to apply the simplification strategy, or we are going to apply the factorization strategy, or we are going to apply the identity strategy. So we already know what strategies to apply in our problems. So we take the most complicated side, which is obviously in this case we are going to say left hand side is equal to cos x minus cos to the power 3x over cos x minus cos x sine squared x. Now we look at this. Look at the numerator. Look at the denominator. We have 2 terms in the numerator. We have 2 terms in the denominator. In the numerator, simplification. Is there a simplification that we can apply in the numerator? Definitely not. No addition and subtraction of like terms. These are not like terms. There's no fractions. There is no reduction formula. There's nothing. So basically no simplification. So we move on to the second strategy, factorization. Is there a type of factorization we can apply in the numerator? Yes. What is it? We can see there's a highest common factor. What is the highest common factor? Cos x and cos to the power 3x. What is the highest common factor, guys, in the numerator that we need to take out? Thank you, Kanye. It's cos x. Then we are left with what inside the denominator, inside the bracket? Thank you, phone 1 in the left hand side and on the right. Phone home, I hope you're not saying cos 2x. It can't be cos 2x. Negative, yes. Negative what? Cos, thank you, Lebogang, squared x. Okay, yes. Then we go to the denominator. If we look at these two, factorization, that can be done. Highest common factor. Thank you. Another cos x. What are we left with inside? I understand, phone home. We're left with what in the bracket? Yes, thank you. 1 minus, but hopefully I know you guys were meaning to say there's a squared. Kanye is more. Yes, BK, you need to teach the people there how to write the exponent. 1 minus sine squared x. Okay. Then we go back to our strategy. We've applied factorization. Okay, we go back. Is there any simplification that can be done further here? Yes. Cos x and cos x, they can be cancelled. Why? Because in the numerator we officially have one term. The relationship between cos x and this bracket is one of multiplication. The relationship between cos x and this bracket is also one of multiplication. So that means cancellation can happen between the products. Cos x and cos x can be cancelled. Alright? Because they are common. You can divide cos x divided by cos x basically leaves you with 1. That's what we mean by the cancellation. Okay? And we can cancel as long as it is not across a addition or subtraction sign. We can cancel these two because it's not across. The relationship between cos x and this bracket is one of multiplication, so cancellation can happen. For instance, you cannot cancel this 1 and this 1. You can't. Why? Because they are across a subtraction sign. You cannot cancel this and that. It's wrong to do that. We don't do that. It's like if there was cos squared x and the cos squared x here, for instance, and there was different numbers here, we wouldn't be able to say we're cancelling this and that. Okay? Why? We do not cancel across an addition or subtraction sign. Okay? So in the now present expression that we have, okay, since we were able to simplify with the cancellation, the question is, do we have any further simplification that can be done here? No. So the simplification strategy is done. Do we have any further factorization that can be done here? Okay. For the purpose of this problem, no. So the factorization strategy is out. Do we have any identities? Look at the numerator, look at the denominator, and look at your answer that you want. So 1 minus cos squared x is the identity sine squared x. Over 1 minus sine squared x is the identity cos squared x. Okay? Yes, Lebogang. Then finally, what is sine squared x over cos squared x. It is your identity again, because there's no simplification strategy that can be applied here. There is no factorization strategy that can be applied here. What can then be applied is the next strategy, which is the identity, tan squared x. But isn't this the right hand side? It is. It is. So therefore our final answer is truly indeed. So we can conclude that the left hand side is truly equal to the right hand side. Identity proven. I hope you guys are good and are well, and it's clear what's happening here, and it's very clear. Okay, what do you want me to repeat, BK? So if we relook at the question again from the top, second from last step. Okay. So just back here, remember after cancelling we got 1 minus cos squared x over 1 minus sin squared x. And after I'm doing this, I'm checking, okay, simplification strategy. Can we apply the simplification strategy further? No. Strategy number 2, can we apply factorization here? No. Identity, can we apply identity? Yes, we can. So 1 minus cos squared x, we can apply the identity approach, because 1 minus cos squared x, remember that identity, the one that says sin squared x plus cos squared x is equal to 1. You guys also need to know that if you make sin squared x the subject, you take cos squared x to the other side. Sin squared x is equal to 1 minus cos squared x. Because sometimes you're going to have to replace this with that, or vice versa. Replace that with this. You also need to know when cos squared x is the subject, still using the same identity, cos squared x is equal to what? Take sin squared x over, it becomes 1 minus sin squared x. When you know these expressions, then you know you can write this as that, or you can write that as this. So in this situation, what's 1 minus cos squared x? Look, it's equal to sin squared x. There it is, the identity. Okay, the identity. No, this is not reduction, it is identities. Okay, there are two identities that we do in grade 11 trig. The first identity is called the quotient identity. This identity here, tan theta is equal to sin theta over cos theta. This tan theta can be written as that. Okay, this is called the quotient identity. Quotient means divide. Okay, so the division between sin theta and cos theta is equal to tan. Okay, then there is also the square identity. Which is sin squared theta or x, or whatever variable you want to use. It just stands for the angle. Sin squared theta plus cos squared theta, or sin squared x plus cos squared x is equal to 1. This is called the square identity. So we also utilize it to be able to, because since we know that this is equal to 1, if we make sin squared x the subject, then it means sin squared x is equal to 1 minus cos squared x. If we make cos squared x the subject, then it means cos squared x is equal to, you take the sin squared x over, it becomes 1 minus sin squared x. So this is not under reduction formula, it's under the identities. So that's why I convert this to sin squared x, and I convert this to cos squared x using the identity. Then finally and lastly, sin squared x over cos squared x is equal to tan squared x. How? Because of this quotient identity. And maybe you're asking yourself the question, but isn't tan theta is equal to sin theta over cos theta? How did you then write this to become tan squared x? Remember, if we are just going to apply simple rules, if we square the left hand side, what do we have to do on the right hand side? We would have to also square it. And remember, when you apply this, the exponent to the numerator and the denominator, this becomes sine squared theta over cos squared theta, which therefore means tan theta becomes tan squared theta. Okay, so basically it's very important to note that this quotient identity can therefore obviously be, we can take the square on either side, we can take to the power of 3 of either side. If there was to the power 3, it means this would be sine to the power 3 theta over cos to the power 3 theta, which is equal to tan to the power 3 and then theta. Okay, so whatever exponent you apply would basically be relevant for this particular identity. So that's why sine squared x over cos squared x is equal to tan squared x. And that's it. Okay, that's it. So I don't know if guys, we can basically see this. That's why I'm saying to you, 3 important strategies. Simplification. You change between simplification, factorization, identity. Simplification, factorization, identity. Simplification, factorization, identity. Simplification, when it's been exhausted, you move on to factorization in that order. When factorization has been exhausted, you go back and check, is there simplification? If there's not, you check, is there factorization? If there's not, then you go to identity. Please, people, sometimes you will get to a problem and you can see there's no simplification, there's no factorization, so that means identity will be utilized. You are constantly choosing, chopping and changing between these 3 strategies. That's why when you do trig, your algebra needs to be on point. If your algebra is not on point, trig will teach you serious lessons and you will not like it. Okay, very important. Another example. Okay, let's go to another example. Tan squared x cos squared x plus sine squared x over tan squared x is equal to 1. Guys, hopefully you can see. So as per the method I taught you, method 1, method that we use, we choose the complex side, very importantly, first step. Then 2, we simplify it. How? 3 strategies. Simplification. Remember, with simplification, you are checking, are they like terms? You add and subtract them if they are. Is there fractions? You basically add and subtract the fractions, remembering that you must get the LCD, utilize your LCD to basically make the denominators the same by multiplying by a particular multiple, top and bottom, exactly, then being able to add the numerators because the denominators are the same. Reduction, please guys, 180 minus, 180 plus, 360 minus. Also remember 90 plus, 90 minus, 270 minus. Those are your reduction, your co-ratios as well. That's also under simplification. Multiplication and division of fractions as well. The rules that apply to that. That's all under simplification. Multiplying out, FOIL, expanding, monomial by a binomial. That's all under simplification. Your strategies under simplification. If that one has been exhausted, you then move on to factorization. Don't forget all your different types of factorization. Highest common factor, dots, trinomial quadratic factorization, grouping factorization, cubic factorization. It depends on the situation. Okay, I'm just gonna write here cubic because sometimes people forget that one. Okay, 3, your last strategy, identities. That's why you need to know your square identities as well as your quotient identity. You are constantly changing between these 3 strategies. Now check me do this question and use exactly what I've just explained to you. Now, the first thing that you are seeing here, you can see that there's tan squared x, which is multiplied with cos squared x, plus sine squared x divided by tan squared x. So before, what about taking a common bracket? That's all under highest common factor factorization. Remember, because highest common factor factorization, when you take a common bracket, you are taking out a binomial highest common factor. Okay, so it's all under highest common factor factorization. So that's also, I guess, for the purpose of people understanding a bit more. Let me write that as well. Highest common factor factorization, common bracket. Okay. One step after grouping, common bracket. Okay. Okay, so let's look at this one. Tan squared x times cos squared x plus sin squared x over tan squared x. When I look at this problem, I'm like, okay, I can see this plus I can see that. So in my head, what is ringing is this is the left hand side, this is the right hand side. Take the complicated side. That's the first step that we said. So we rewrite this tan squared x cos squared x plus sine squared x over tan squared x. Then maybe one will say fractions, but I am saying before that you have tan squared x times cos squared x. This is multiplication. So in my head I have BODMAS ringing in my head, which is also a simplification strategy, because if you don't have like terms, right, you don't have like terms, the next thing you need to check BODMAS. Here there's multiplication. We first deal with multiplication. Division and multiplication we must deal with before we add, right? So I'm going to first take this tan squared x and multiply it by sine squared x, all right? But the thing is, in order to multiply, factorization, the next strategy is not the one. The next strategy is what? It is identity. So tan squared x can be written as sine squared x over cos squared x multiplied by cos squared x over 1. Then plus sine squared x. Now guys, this here is the division line. So what I'm going to do, I'm going to say divide by tan squared x is sine squared x over cos squared x. I'm doing this deliberately because I can see that there's a potential simplification of these two and these two before I add. I hope that makes sense. So I use my identity so that I can be able to multiply this, and also with this division, obviously this divide I'm going to change to multiply, and what happens when I change that divide to multiply? This fraction becomes cos squared x over sine squared x. Yes, swap, very good. Now I can attend to these at the same time. Sine squared x over cos squared x times cos squared x over 1. You guys know for a fact that this and that says goodbye, because cos squared x divided by cos squared x leave me with 1 and 1. Okay, same thing this side. Sine squared x over 1 with this sine squared x in the denominator leave me with 1 and 1. So already I'm sure you guys can see that for this side, what do I have? I'm left with sine squared x. It's in the numerator, the sine squared x. Sine squared x times 1 is sine squared x. 1 times 1 in the denominator is 1. So sine squared x over 1 is sine squared x. Plus, look at this one. I cancel these two. Sine squared x divided by sine squared x leaves me with 1 and 1. 1 times cos squared x leaves me with cos squared x in the numerator over 1, because 1 times 1 is 1. What is this? Go back to my strategies. Simplification, no simplification. Factorization, no factorization. Identity, yes. Yes, eminently. 1. This is the right hand side. You see, guys? Hey, guys. This is when the maths is mathsing. This is when the maths is flowing, bruh. When it's flowing, it's flowing. You can't stop it. You can't stop the river of maths flowing. Okay. So this is it. This is basically how we maneuver and we go about doing these problems. So therefore, we can conclude a left hand side is equal to the right hand side. So if you guys can just get these strategies down, you are constantly moving between. You have an awareness, because when in lower grades, you've been doing problems when you have many operations. This is tan squared, it's times by cos squared x. There's a plus, this is sine squared x divided by tan squared x. So you change, so first things first, you're like, okay, simplify. Is there any simplification? Okay, there's multiplication between two things. But the thing is, in your head already, you're like, hey, a key identity. So factorization, after simplification, factorization is out, but I want to multiply these two. So what do I apply? Identity. So change this identity. Multiplication, the simplification, it can happen. Plus, sine squared x over tan squared x. Hey, tan squared x. This is a division. So I say sine squared x divided by sine squared x over cos squared x, because tan squared x, identity. You see? Identity. Then after that, gone. Left with sine squared x in the numerator. This side, gone. Left with cos squared x. This identity, because simplification can't be done. Factorization, don't need it. Identity, 1. Answer, done. This was the original question. Took the complicated side, applied simplification. We could see board mass is crying. Multiplication wants to be done. Division wants to be done. Addition was going to be taken care later if there is anything that has to be added. But obviously, it led us to another identity, and then we were able to get our final amazing right hand side, which is 1, as we had required it. Okay, then I'm gonna do one last one, guys, so that I can love and leave you, so that I can prepare to leave for work, because you guys are enjoying. Okay, so please, guys, I want to go back to this, the strategies for simplifying or proving identities. Method 1, you first choose the complex side. 2, you simplify it. How? 3 strategies, guys. There's simplification. Hey, like terms, if they are, you take care of them. Okay, I'm now going to add here bed mass. Why bed mass? Because if there are many operations in your expression, then you must consider brackets, exponents, division, multiplication, addition, and subtraction. Okay. Addition and subtraction of fractions, if there's anything. Reduction, application of reduction, whether it be co-ratio or function value. Multiplication and division of fractions. Don't forget that. When you have exhausted simplification fully, then you can move on and check the strategy of factorization. Check factorization. If factorization can be done, do it. When you have completed doing factorization, you go and check back again. After doing factorization, is any other simplification, can it be done? Okay. If not, guys, you check your identity, which is the 3rd strategy. So you are constantly checking between simplification strategy, factorization strategy, and identity strategy. As long as you are doing that and always constantly checking, I don't care what the problem is, guys. If you guys can do the algebra and you know everything, asuka, it's not gonna, I don't care how it comes. You'll always be winning. You'll always win. There's no losing. Level 7 is coming. It is calling. It's calling your name. 100% is calling your name. 1 minus cos x over sin x. I'm doing this. This is my last one before I leave, guys. I have to prepare and go. Work is calling. 1 minus cos x over sin x minus sin x over 1 plus cos x. Okay, so we have a left hand side. We have a right hand side. Okay. Now, once again, what do you have here? 1 minus cos x over sin x minus sin x over 1 plus cos x. First strategy, what did we say? Simplification. With our simplification strategy, we can see, guys, that this is a what? This is a addition and subtraction of fractions. This is not an identity, this is not an identity, this is not an identity, this is not an identity. There's no factorization. So we're going straight to simplification, subtraction of two fractions. What did I tell you just not so long ago? I said you can do the following. Multiply this with that. So in other words, 1 minus cos x into 1 plus cos x. There. You multiply this with that. Minus sine x into another sine x. This sine x times the sine x with the negative sign. Over the last thing, you multiply your denominators to get the denominator value. Sine x into 1 plus cos x. And initially, I love leaving the denominator in this state. Don't multiply it in yet. Okay. Then, let's look at the numerator. We can now add and subtract the numerator, but you can see that there's multiplication, meaning there's a binomial by a binomial. We can multiply this out, and then this negative sine x needs to be multiplied with this sine x. So let's do that. 1 times 1 is 1. 1 times positive cos x is plus cos x. Negative cos x times 1 is negative cos x. And then negative cos x times positive cos x is negative cos squared x. Negative sine x times sine x gives me negative sine squared x, which is great over sine x into 1 plus cos x. Leave that like that for now. Yes, Luba, very good. We got the identities. And 1 cos x minus cos x, we add and subtract the like terms. We are still simplifying before the identities. 1 minus cos squared x minus sine squared x over what? Sine x over 1 plus cos x. Okay, seems like we're still going. Then 1 minus cos squared x. No factorization can be done. Simplification, there's no other addition and subtraction of like terms, so simplification and factorization strategy has been exhausted. Then we go to identities. 1 minus cos squared x is an identity. It's equal to sine squared x minus another sine squared x over the sine x into 1 plus cos x. You see how we are constantly switching between simplification, factorization, identity, simplification, factorization, identity. Now, sine squared x minus sine squared x, like term, simplification, that's equal to what? 0 over sine x into 1 plus cos x. But of course, 0 divided by anything is equal to 0. What was the question? Equal to 0. That is the right hand side. So this is the RHS. Therefore, we say LHS is truly equal to right hand side. Guys, let me love and amazingly leave you. Hopefully this morning session was very refreshing. It was reviving. Yeah. Compliment. Do you know what? Actually, I actually have it on good knowledge that people tend to say my handwriting is actually quite bad. So for you to say that Ririsoko is very kind, thank you. I know how terrible my writing is. I've many times said that I should be a doctor. I should have been a doctor, profession-wise. Do I teach? It's Chris. Yes, I do. I have to head to work now. I teach, and I teach very well. This is not to boast, but I teach very well. I teach very simplistically so that people can understand, and that is because I know. So I hopefully, like I said, this is helpful to you. These strategies for identities, guys, like I said, simplification, factorization, identity, constantly changing between these three. Simplification, factorization, identity. It's like, it's like the SFI. In order to unlock the identity, you need to apply SFI. Mathematicians mostly write badly, my guy, don't worry, I saw that on Mishi. No, totally we do, man. Totally we do. Guys, I will be doing the live session in the mornings, as well, and also this afternoon, this evening, after 8, I'll be back again. Okay, so I'll teach. I'm trying to wake up very early. Hopefully, I can get off the blocks every morning at 5 a.m. instead of getting off the blocks at 5 a.m. So I'm trying to wake up very early so that I can get myself prepared and ready. Then I can start live lessons in the morning at 5 a.m. All right. I was supposed to have a session with the grade 12s, but someone ended up coming on the session, which was grade 11, and they asked about identities, and that's why you see me ending up doing identities. That was not my plan, but because a particular person said let's do identities, I did it. Okay, so I think I'll play by majority of who comes in, and then I'll push that thing in the mornings, or do grade 12 if people actually do come and join in. So I will actually download this video. I'll be uploading it onto my YouTube channel. So those that don't know, I have a YouTube channel. It's quite new. It's not the best. Really and truly, guys, it's raw. I just upload these sessions as they are onto my YouTube channel, and people can go and watch. Thank you so much, Slayer TK for the gift there, that 2025 one. So I'll upload this on my YouTube channel, so it will go under the grade 11 playlist for identities. I'll upload it as it is, and then you can watch it, or you can, if there are people who are here that felt like, oh, my friend could have really benefited from this, they can go there and they can rewatch the session. The quality, of course, of the videos is per the TikTok videos. I don't have an iPhone, I have this phone, so I'll upload that, and then people can watch it, and they can watch it as many times as they want, just so that you can get this thing in the bag. I know control tests are coming up for most people. They'll be writing in March, some of you. Those are coming up, so we need to make sure that we solidify what we've learned in class and own it, and own it more than anything else. Master is possible. 100% for a grade 11 learner, very possible in term 1. So let's do this, let's play the game. Maths is a game, let's play. That's the concept behind my lessons, because we just play the maths, man. We play the maths and we kill it, we get 100%. There's no funny business. Level 7 is no question, we get level 7. We don't joke around here. Okay, so see you later on this evening, those who will be joining in, or else I'll see you tomorrow morning. And thank you so much. Have a good day. Stay blessed.